The water fuel cell. In 1998, in a modest Ohio neighborhood, inventor Stanley Meyer stepped away from a restaurant lunch and collapsed in the parking lot outside. Those nearby heard his final words. "They poisoned me," just moments before he had been talking about a discovery that, if real, would have completely reshaped the global energy landscape. A vehicle running not on gasoline, but on water. Stanley Meyer was no eccentric dreamer. He had secured patents for a water fuel cell, conducted several public demonstrations, and drawn interest from both private investors and government intelligence. His apparatus, fitted to a converted dune buggy, reportedly broke apart water molecules into hydrogen and oxygen through a process known as electrolytic dissociation. Yet Meyer insisted his version consumed so little electricity that it defied the established laws of thermodynamics. Simply put, it functioned in ways it shouldn't have. His water-driven vehicle was captured on film traveling down open roads, a soft trail of vapor rising from the exhaust. No gasoline, no emissions, water alone. He turned the key and spoke. "This is what tomorrow looks like." The U.S. Department of Energy never officially evaluated the device. Even so, Meyer's story spread. News organizations picked up his work. NATO researchers reached out to him. Overseas interests, some allegedly connected to the Middle East, reportedly made offers to acquire the technology entirely. He walked away from every deal. On the day he died, Meyer sat across from two Belgian investors over a meal. His brother, Stephen Meyer, later said that Stanley bolted from the restaurant gripping his throat, retched, and fell to the ground. His death was attributed to a cerebral aneurysm. No trace of poison was found. No investigation followed. The prototype was removed. The patents expired. The workshop was cleared out. Afterward, engineers who attempted to rebuild Meyer's design discovered that the core blueprints contained gaps, as though critical information had been deliberately stripped away. Some concluded the energy input vastly outweighed the output. Others observed that Meyer relied on unconventional parts, modified transformers, pulse frequency circuits, and precision resonance tuning, pointing to a very narrow, fragile configuration that was never made available to the public. To this day, the original water fuel cell has not been found. The patents exist, but contain missing pieces. Engineers who tried to replicate the results describe equipment malfunctions, shorted circuits, and failures they cannot explain. Online communities dedicated to Meyer's legacy are buried in contradictory data and broken trails. If Stanley Meyer genuinely discovered a way to power engines with water, it would have rendered the oil industry obsolete, upended geopolitical power, and transformed the global economy almost overnight. And if that threat was real, then powerful interests had every reason to make sure his invention never left the room. The electric car recall. In 1996, amid quiet optimism and heightened expectations, General Motors launched the EV1, the world's first mass-manufactured electric vehicle. Near silent and far ahead of its era, it was offered to drivers in California and Arizona as a machine that consumed not a single drop of gasoline. Those behind the wheel described the experience as gliding across pavement. Yet within a few short years, every single EV1 was tracked down, reclaimed, and crushed by the same company that had built it. The EV1 was not an experiment. It was a road-ready electric car capable of 100 miles per charge, equipped with regenerative braking and zero emissions. It came with its own ecosystem. Charging infrastructure was installed across major cities, and GM poured resources into positioning it as the vehicle of the future. Despite the battery constraints of the time, the EV1 outperformed expectations. Drivers were devoted to it. Waiting lists formed. Then the mood inside GM shifted. By 1999, word began to circulate that the program had lost corporate support. The lease terms, notably, never permitted drivers to purchase their vehicles. In 2002, GM launched a systematic campaign to repossess every EV1 on the road, even from drivers, who had no complaints and wanted to keep their cars. Some pushed back. A number offered to buy at full price. GM declined. Car by car, the vehicles were collected and hauled to a fenced facility in the Arizona desert, where most were destroyed. No safety recall was ever issued. No mechanical failures were disclosed. The company cited maintenance overhead, battery shortcomings, and low demand. but documents that later surfaced revealed that GM, in coordination with other manufacturers and fossil fuel interests, had quietly pressured California to dismantle its zero-emission vehicle mandate, the very regulation that had pushed GM to develop the EV1 to begin with. Internal communications hinted at deeper concerns, fears that the EV1 would force an infrastructure overhaul, eroding gasoline revenues, parts distribution networks, and the business models of dealerships that depended heavily on servicing combustion engines. Electric cars required less maintenance, fewer oil changes, fewer components to replace, too little revenue per vehicle. A small number of EV1s survived, mostly in institutions, their drivetrains removed, permanently disabled. Former engineers and program directors went on record years later describing the cancellation as a corporate execution. Chris Payne's 2006 documentary, Who Killed the Electric Car, laid out persuasive evidence that the EV1 didn't collapse on its own. It was eliminated. Electric vehicles are everywhere. But long before Tesla, Rivian, or Lucid ever existed, the EV1 was already on the road, and then with deliberate precision, it was erased. What changed wasn't the engineering. What changed was who stood to gain from it. The Tesla Power Tower. In 1901, on a windswept bluff in Shoreham, New York, a towering structure began taking shape, not a weapon, not a radio mast. A machine built to deliver electrical energy invisibly through open air. Its architect was Nikola Tesla, the brilliant and unconventional inventor who believed he had unlocked a method for transmitting unlimited electrical power without a single wire. He named it Wardenclyffe Tower. He believed it could illuminate the entire world. Within a few years, however, the project was abandoned, its backing withdrawn, the tower torn apart. Tesla's ambition was not delusion. His prior experiments had already demonstrated the possibility of long-distance radio transmission. But Wardenclyffe aimed at something far more profound, the wireless delivery of electrical power, by harnessing the Earth's natural resonant frequency. The tower's copper dome, deep grounding rods, and high-voltage coils were not decorative. They were calibrated components of Tesla's planetary energy theory. His vision was elegant, radical, and deeply threatening. A worldwide network of towers, transmitting free electricity to any receiving point on the globe. No cables, no utility companies, no billing, no gatekeepers. The project was initially financed by J.P. Morgan, shrouded in secrecy. Tesla spoke in public about cross-Atlantic messaging and even contact with Mars. But in private, he disclosed to Morgan that his actual objective was to dismantle the centralized energy system entirely. That admission ended everything. Morgan withdrew his support. No other investor materialized. Construction ceased in 1905. By 1917, the tower was demolished, supposedly for salvage. Official records pointed to insolvency and technical failure. But private letters and later testimonies told a grimmer story. Tesla's system, had it succeeded, would have destroyed the emerging energy monopolies before they consolidated. Morgan's reported question said everything. Where do we put the meter? It wasn't a technical objection. It was a business one. Power that couldn't be measured and charged for was not progress. It was a threat. Tesla's Wardenclyffe notebooks disappeared after his death. Some were allegedly seized by the U.S. Office of Alien Property, despite involving no foreign nationals. Others were sold at private auction or simply never recovered. The most complete surviving diagrams hint at a functional system, one that remains poorly understood today. In the decades since, engineers attempting to reconstruct the design have run into inexplicable obstacles, arcs that fail to appear, resonances that collapse without cause. Tesla himself suggested the system depended not only on the machinery, but on specific electromagnetic conditions of the planet, conditions that, once disrupted, may be gone permanently. Had the Wardenclyffe Tower operated as Tesla envisioned, the world would be unrecognizable today. The age of wires, batteries, and fossil fuel grids might never have taken hold. The tower was pulled down, and with it, perhaps the only real chance at energy without gatekeepers. The Eternal Lightbulb. In a fire station in Livermore, California, a single bulb has been burning since 1901. Known as the Centennial Bulb, it hangs from the ceiling, casting a warm amber glow around the clock, every day. It has outlasted 2 world wars, major earthquakes, and every technological shift of the modern era. It has outlived every other object in the building, and most remarkably, it still works more than 120 years later. This small, overlooked object may be the most powerful evidence of an uncomfortable truth: that we once knew how to build things that lasted indefinitely and then made a choice to stop. Produced by the Shelby Electric Company in the late 1800s, the bulb was made using a hand-blown glass casing, thick coiled filaments, and compounds no longer used in modern manufacturing. Researchers studying its lifespan point to its filament, carbon-based and slow-burning, in contrast to modern tungsten filaments that burn with more intensity but burn out far sooner. The Centennial Bulb is not a fluke. In the early 1900s, bulbs from the same period regularly lasted decades. Some burned continuously for over 60 years inside factories and mines. Then, in the 1920s, something changed. That change had a name: the Phoebus Cartel. In 1924, a covert alliance was formed between the world's dominant light bulb manufacturers, General Electric, Philips, Osram, and others. Their agenda was not advancement, it was limitation. Recovered documents revealed that the cartel agreed to artificially restrict bulb lifespan to 1,000 hours. Engineers who produced bulbs exceeding that threshold were disciplined. Designs were quietly modified. The outcome was a calculated early version of planned obsolescence. Consumers would need to replace bulbs more frequently. Revenue climbed, and the world was steered toward forgetting that longer-lasting light had ever been within reach. Efforts to bring back the original designs have stalled. Shelby's original manufacturing records are fragmented. Labs that reverse-engineered the Centennial Bulb's materials identified a formula incompatible with modern production infrastructure, not because the ingredients are scarce, but because they don't serve the supply chains and business models built on repetitive consumption. The Centennial Bulb still glows. It has a live webcam, followed by thousands who watch in quiet amazement. But its existence poses a deeply unsettling question. If we once knew how to engineer something to last more than a century, what other knowledge have we accumulated and then quietly buried in the pursuit of profit and control? The Eastern Air Cleaner. In the early 1990s, within the decaying industrial corridors of post-Soviet Eastern Europe, a team of engineers introduced a machine that promised to eliminate air pollution entirely. Developed in secrecy by a collective of former military scientists on the outskirts of Krakow, Poland, the device was compact, boxy, and completely silent. It could cleanse the air of an entire space in minutes, targeting not just smoke or particulates, but toxic industrial chemicals, airborne pathogens, and microscopic contaminants at the molecular level. The prototype functioned through a form of cold plasma filtration, paired with an electrostatic field that altered the electrical charge of airborne matter. As pollutants entered the device, they weren't simply captured, they were broken down, their molecular structure dismantled without releasing any secondary byproducts. No filter changes were needed. It consumed almost no energy, and it worked. Independent evaluators were stunned by the results. In one trial, the machine eliminated formaldehyde and benzene from a sealed environment within 11 minutes. In another, it cut PM2.5 contamination in a warehouse by 98.6% within a single hour. The team brought their findings to regional governments and international environmental bodies. Early responses were encouraging. One official reportedly described it as the most disruptive environmental technology seen in years. But within weeks, the project went dark. The explanations were vague: regulatory complications, unresolved patent matters, missing industrial certifications. Behind closed doors, the team described a pattern of escalating hostility. Their chief engineer was detained at a customs checkpoint. Shipping containers holding new units disappeared in transit. Funding agreements were canceled without notice, and partner laboratories were directed to suspend all work. By 1994, the company had dissolved. The core team scattered across the continent. Years on, one member came forward anonymously, alleging that a corporate network with ties to HVAC manufacturers and petrochemical interests had absorbed the remaining assets and buried the project beneath layers of shell companies. No working prototype remains accessible to the public. Efforts to reconstruct the system from surviving schematics have all come up short. Researchers report critical gaps, particularly around the plasma ignition mechanism and frequency harmonics. It is also noted that certain materials used in the original build were placed under export restrictions after 1995, classified as dual use under European law. Certain surviving documents list potential medical uses for the technology, indicating it could disinfect hospital environments, neutralize airborne pathogens, and reduce the transmission of viral illness. None of those applications were ever tested. In a world suffocating under urban smog, navigating respiratory pandemics, and confronting record-high asthma diagnoses, the disappearance of a technology like this feels less like an oversight and more like a calculated removal. If we once possessed the means to purify the air completely, why was it taken, and more urgently, who decided we weren't allowed to breathe freely? The vacuum energy engine. In 1983, in a suburban neighborhood outside Toronto, an independent engineer named Troy Hertu-Bice claimed to have constructed a small engine capable of running indefinitely, drawing not on fuel, electricity, or combustion, but on the controlled manipulation of vacuum pressure. The prototype, an unusual assembly of copper coils, magnets, and titanium plates, fit inside a shoebox. When switched on, it produced a low, steady hum and began spinning a connected flywheel with no external power connected to it. By its creator's account, it was a self-sustaining energy machine, and it unsettled everyone who witnessed it operate. Hertu-Bice had no investors behind him, no academic credentials, and no legal representation. What drove him was a fixation on magnetic fields and a deeply unorthodox grasp of physical principles. He called his creation the Angel Light Engine, a name rooted in his conviction that it accessed natural forces that mainstream science had yet to recognize. He assembled it from military surplus components and salvaged MRI equipment. On first glance, it resembled an elaborate hobby project. But when he brought in journalists and engineers to observe it, something they couldn't explain happened. The engine activated and kept running. Witnesses stated that the device not only sustained itself but generated sufficient torque to drive mechanical systems. Hertu-Bice described the engine as operating through a vacuum inversion chamber, in which opposing magnetic fields produced a sustained differential pressure, emulating the vacuum energy theorized to exist in deep space. It was, in his words, a machine that drew energy from nothing and returned more than it consumed. Shortly after his demonstration became public, Hertu-Bice was approached by individuals he described as men in suits. They questioned him about his history, the origin of his components, and his intentions regarding patents or sale. 1 week later, his workshop was destroyed in what investigators ruled an electrical fire, despite the building having no power connection and no active electricity at the time. Nothing of the engine survived. Hertu-Bice attempted to rebuild, but reported ongoing surveillance, disrupted deliveries, and repeated acts of vandalism. He withdrew from public life, eventually reappearing with new projects, including impact-resistant armor and electromagnetic tools, but he never spoke of the vacuum engine again. In 2018, he died in a single-vehicle accident under circumstances that were never fully clarified. Skeptics treat the account as textbook pseudoscience, an overreaching inventor pursuing impossible physics. Others highlight the coherence of his claims, the corroborated testimony of witnesses, and the convenient timing of the fire. The vacuum engine was never formally assessed, yet its story endures as a reminder of what might have existed: a power source free of pollution, free of infrastructure, and beyond the reach of any controlling interest. If vacuum energy is real, and if someone once found a way to use it, what would that mean for every industry built on artificial scarcity? What happens to the world when energy can no longer be owned? The infinite battery. In 1973, a retired aerospace engineer named Carl Kordesh introduced a prototype battery so long-lasting that it threatened to make multiple industries redundant. Originally conceived for use in long-distance military communications and orbital systems, the unit merged alkaline and hydrogen fuel cell chemistry into a single power source capable of running without interruption for up to 50 years, requiring neither replacement nor recharging. It was compact, capable of regenerating itself, and remarkably efficient. But after brief testing and minimal press attention, the project was locked away beneath decades of corporate silence. Kordesh had already contributed to the development of the first alkaline battery and had worked on early fuel cell systems for NASA. His breakthrough came from combining the chemical stability of alkaline manganese dioxide with a sealed hydrogen loop, enabling the battery to restore its own charge during use. Unlike lithium-ion cells, which degrade progressively and depend on high-impact, often dangerous extraction of raw materials, Kordesh's design relied on common elements and minimal moving parts. It produced a steady current even at rest, and remained functional across extreme temperature ranges. When he presented it to regulators and potential corporate partners, the reception was cold. One executive from a major electronics company reportedly said, "A battery that outlasts all our products isn't something we can build a business around." No licensing agreements followed, no testing contracts were extended, and despite the potential to transform personal electronics, transportation, and space systems, the design was shelved. Materials from Kordesh's personal records, later released by his estate, documented pitches made to governments and corporations around the world. Nearly every meeting followed the same arc. Initial curiosity, then silence. He was steered toward focusing on more commercially viable alternatives, meaning products designed to wear out. Patent applications for the regeneration system stalled, under objections citing insufficient industrial applicability. In 1982, a private investor tried to revive the technology through a new venture, marketing it as Power for Life. The company folded within 6 months. Not a single unit reached production. The remaining prototypes held in storage were seized during a regulatory inspection under the banner of compliance review. They were never returned. The battery industry remains locked in cycles of deliberate obsolescence. Smartphones, electric vehicles, and tools all require regular recharging or eventual replacement. Behind each cycle lies a growing pile of electronic waste, hazardous extraction operations, and profit structures that depend on failure. What if none of that was ever necessary? What if the ideal battery had already been built and quietly eliminated because permanence was a threat to the marketplace? The magnet drive motor. In the late 1970s, a little-known physicist named Howard Johnson filed a patent application that would later be labeled impossible, unprovable, and by others strategically buried. His assertion was bold, that he had engineered a magnetic motor capable of continuous rotation with no fuel, no combustion, and no electrical input. The device, driven entirely by the repulsion between permanent magnets, could spin indefinitely once set in motion. In 1980, to widespread disbelief, the U.S. Patent Office issued patent number 4,151,431 for a permanent magnet motor. Then, almost immediately, the subject went quiet. Johnson's design was geometrically straightforward. A series of curved permanent magnets positioned along a stator, working in tandem with matched magnets on a rotor. As the magnets advanced past one another, they produced a cascading push force, a progression of rotational energy that appeared, at minimum in demonstrations, to sustain itself without input. Critics dismissed it as an illusion. Physicists argued it contradicted the second law of thermodynamics. But Johnson maintained that the motor was not generating energy from nothing. It was releasing stored potential locked within the magnetic field itself. He demonstrated it privately for journalists, researchers, and investors. Some were persuaded, others remained unconvinced. What no one disputed was this: the device behaved unlike anything in known mechanical science. The scientific establishment responded with swift rejection. Leading journals declined to publish his work. Laboratories that attempted to replicate the motor either came up empty or described strange anomalies in their test environments. Disrupted magnetic fields, spontaneous demagnetization, inexplicable mechanical instability. Some theorized the motor relied on material tolerances and alignments so exacting that reproduction was impossible, without Johnson's original components and setup. As attention grew, pressure mounted. Legal disputes arose over the boundaries of his patent. Multiple companies that had expressed interest in licensing the design quietly backed away. One collaborator alleged that structured offers were made to buy and suppress the patent at a price designed to guarantee Johnson's permanent silence. He declined. By the late 1980s, funding had dried up. His health deteriorated. Public appearances became rare. In one of his last documented statements, he said, "They didn't have to disprove me. They just had to outlast me." He died in 2008. His motor never manufactured at scale. His work left behind in obscure patent filings and scattered technical documents. To this day, the concept of a magnetic motor is treated as taboo in mainstream science, dismissed as pseudoscience or delusion, despite the documented existence of the patent. But if Johnson was correct, even in part, his invention may have unlocked one of the last untouched sources of mechanical energy, quiet, clean, and beyond corporate reach. The question persists, did his motor defy the laws of physics? Or did it defy something far more powerful, the laws of profit? The trash fuel converter. In 2003, inside a warehouse on the edge of São Paulo, Brazil, a small engineering team unveiled a device they were convinced could solve two of the world's most urgent problems simultaneously: energy scarcity and waste accumulation. Their invention, roughly the footprint of a shipping container, could transform ordinary household refuse into high-grade, clean-burning fuel. No smoke, no emissions, no hazardous residue. Garbage in, gasoline out. The method behind it was a closely held innovation, built on thermal depolymerization, amplified by proprietary catalysts and pressurized reaction chambers. Unlike incineration or standard pyrolysis, their process dissolved organic and synthetic waste. At the molecular level, reconstructing carbon chains into usable fuel with conversion efficiency above 80%. Worn shoes, plastic containers, even organic food scraps, all could be processed into liquid fuel, chemically indistinguishable from commercial gasoline. The team named their project Project Gaia. Early demonstrations attracted local politicians, environmental advocates, and international press. One test ran a diesel generator continuously for 48 hours using fuel sourced entirely from mixed urban garbage. Another batch of fuel passed Brazil's regulatory quality standards. The technology wasn't theoretical, it was operational. Without warning, it was gone. 2 months after a national broadcast brought the project into the spotlight, the facility was raided. Authorities cited violations of environmental processing licenses. Equipment was removed for inspection. Permits were revoked. No one was arrested. No charges were filed. No explanation was offered. The engineers behind Project Gaia stepped out of public view entirely. One reportedly relocated to Uruguay. Another later resurfaced in unrelated software work. All requests for comment were rejected. Attempts to locate the seized prototype ran into redacted paperwork and dead-end regulatory channels. A Freedom of Information request, submitted by an independent journalist years later, surfaced internal correspondence between government bodies and private energy interests. One communication, dated weeks before the raid, flagged disruptive fuel synthesis devices, posing threat to existing infrastructure. Another outlined containment strategies for technologies capable of bypassing conventional refining networks. The waste crisis has deepened. Landfills are at capacity. Plastics saturate the ocean. Energy costs keep rising, yet the Brazilian device that seemed to address all of it has been largely forgotten. Skeptics argue the system likely carried hidden flaws, that scaling it up could have introduced dangerous emissions or unpredictable reactions. But the missing data, the silence of its creators, and the rapid, total suppression of a functional prototype point toward something more troubling. What if waste could become wealth, and someone chose to ensure that discovery never reached the world? The Illness Prediction Scanner. In 2009, inside a modest biomedical laboratory in Geneva, a team of engineers built a diagnostic tool that stood apart from anything in conventional medicine. Roughly the size of a shoebox, the prototype could scan a person's electromagnetic field and identify cellular irregularities well before any symptoms developed. It required no X-rays, no blood draws, no imaging equipment. It charted biofrequency signatures, cross-referencing them against a comprehensive database of disease markers. The results in early evaluations were remarkably consistent. The team named the device Neuroscope. In clinical trials conducted with terminally ill patients, the device reliably detected malignant growths weeks, and in certain cases months, before they appeared on conventional imaging. In neurological assessments, it flagged early-stage Parkinson's and Alzheimer's based on minute shifts in neural resonance patterns. Under controlled conditions, it also identified chronic conditions in patients who had not yet received a formal diagnosis. The foundational concept wasn't entirely unprecedented. Fringe researchers had long theorized that the human body projects a unique electromagnetic signature shaped by its internal condition. What the Neuroscope brought was the ability to measure and interpret those signals using machine learning, biofeedback systems, and sensors, precise enough to detect variations in the body's harmonic patterns. Hospitals in Switzerland and Germany quietly requested access to pilot units. The World Health Organization paid attention. A pharmaceutical executive present at a demonstration reportedly said, "If this holds up, routine screenings lose their purpose." That statement may have determined the device's fate. Within weeks, the company's research authorization was revoked, pending an investigation into data irregularities. Their servers were confiscated. The lead engineer, a Romanian national, was expelled from the country on grounds of visa violations. All production agreements were terminated. Public communications cited questions about medical accuracy, yet no definitive counter-evidence was ever produced. The Neuroscope was erased before it ever reached a patient. Attempts to restart the project through private capital failed. Ownership of the core technology passed to a shell company and has not been active since. Independent researchers who attempted to reconstruct the device from publicly available fragments reported problems during calibration. Some have suggested the original team intentionally omitted critical specifications from their published materials. There are persistent reports that a functional version still exists, operating discreetly in high-security medical facilities. Others maintain it was dismantled precisely because it threatened one of the most financially protected sectors in modern healthcare, early diagnostics. What if a machine could see illness before it took hold, and the people who profit from treating it decided the world wasn't ready? Conclusion: these cases, spread across decades and continents, are not a random assortment of strange stories. They reveal a pattern, a consistent and troubling model of suppression and erasure. They were not frauds. They were not failed experiments. They were functioning systems, dismantled not by the forces of nature, but by the hands of people who looked too far ahead, built too well, and threatened to redistribute power from the few to the many. Each story reflects a methodical resistance, a framework in which breakthroughs are filtered through the demands of profit and control. From Nikola Tesla's wireless energy grid to a waste conversion machine in Brazil, these inventions were never measured by their capacity to benefit humanity, but by the danger they posed to entrenched power structures. The elimination was never dramatic. It moved quietly. Through seized patents, withdrawn funding, unexplained fires, erased laboratories, and lives ended in silence. What was taken was not only machinery, but the future itself. A future where light bulbs needed no replacement, where engines breathed clean air, where pollution became a memory, where disease could be caught before it struck. These were not abstractions. They were turning points, and somewhere, by someone, those turns were blocked. The erasure goes on. Whistleblowers go missing. Independent engineers are discredited. Patents are purchased, buried, and forgotten. These 10 cases may be only fragments of a story far larger. The visible edges of inventions sealed away in time behind closed doors, behind secured vaults, behind enforced silence. The tragedy is not that these technologies fell short. The tragedy is that they worked, and that was exactly the problem.